Understand the strategies for solving logarithmic equations and enjoy the journey of learning. I am Anil Kumar. Welcome to my series on logarithmic equations. Here we have another set of questions where the logarithmic equation might have extraneous roots. In these four questions, you need to find roots of each equation, identify and reject extraneous roots. As you can see, the question has quadratic arguments in it, and in these cases, you might have extraneous roots. Have a good look at it. We are going to solve one by one each and every equation. In the very first video, now let's see how do we solve question number 1. You need to apply similar strategies for rest of the questions to solve. Question number 1 is log to the base 3 of x squared minus 3x plus 5 equals to 2. First step is to write it in exponential form. So we have x squared minus 3x plus 5 equals to 3 to the power of 2, which is 9. Now bring the terms on the left hand side. So we have x squared minus 3x plus 5 minus 9 equals to 0. Combine the constants. X squared minus 3x minus 4 equals to 0. Now factor the quadratic equation. Product of minus 4, sum of minus 3. Clearly the numbers are minus 4 and plus 1. So we get the factors x minus 4 times x plus 1 equals to 0. So that gives you two solutions for this equation. Applying the zero principle, the product of two numbers is 0 means those could be 0. So one of the solution is we can place x minus 4 equals to 0, and that gives you x equals to 4. And we can now place x plus 1 equals to 0, and that gives you x equals to minus 1. So we do have two roots here. However, we need to check if one of them, if it is extraneous or not. So how do we check that part? So let's do the check part. So to check, we'll substitute the value in the argument itself, which is x squared minus 3x plus 5, right? So if I substitute 4 in it, I get 4 squared minus 3 times 4 plus 5, which is equal to 4 squared is 16 minus 12 plus 5, and that is 16 minus 12 is 4, 4 plus 5 is 9, right? And log base 3 of 9 is equal to 2. So we know that log to the base 3 of 9 is equal to 2. So this part is correct. Now let's put minus 1 and then check that part also. So if I substitute minus 1, I get minus 1 square minus 3 times minus 1 plus 5. That is equal to 1 plus 3 plus 5, and that is also 9, right? So that also works. That means we do not have any extraneous root in this particular example. And therefore, we say that the solution is x equals to minus 1 or right? So both are the solutions. Perfect. So that is how we can solve this particular question. Right. I hope the concept is clear. I'd like you to apply the same concept in question number 2 and then solve it. It is very similar to what we did. Now, here is my solution. So, let's begin by writing the equation, which is log of x square plus x minus 2 equals to 1. Write it in exponential form. The base, as you know, is 10. So we get x square plus x minus 2 equals to 10 to the power of 1, which is 10 itself. Bring them together. We get x square plus x minus 2 minus 10 equals to 0. That gives you x square plus x minus 12 equals to 0. Factor. So if you factor it, minus 12 means 4 times 3. 4 should be positive. So we get x plus 4 times x minus 3 equals to 0. Again, applying the zero principle, we'll find the solution. So we have x plus 4 equals to 0, which gives you x equals to minus 4. And we have x minus 3 equals to 0. That gives you x equals to 3. It's a good idea to check, right? So we are going to substitute the values in the expression x squared plus x minus 2 for x equals to minus 4. So we get minus 4 square minus 4 minus 2 equals to 16 minus 4 minus 2, which is 10. And you know, log of 10 is 1, so it works, correct? Now, let's do the other substitution of 3. So when I substitute 3 here, I get 3 square plus 3 minus 2, which is 9 plus 3 minus 2. And that is also 10. So we know log of 10 equals to 1, so that works. Therefore, both are the correct roots. So in this case also, we do not have extraneous root. We get the answer x equals to minus 4 and 3. So we have two solutions to this particular equation. So I hope the concept is absolutely clear. These two examples which we did with kind of quadratic equation as an quadratic expression as an argument was perfectly fine without any extraneous root. Now let's take a radical equation which is 3 log cube root of x squared plus 8x 48x equals to 2. So let's try to see this equation. So we have 3 log cube root of x squared plus 48x equals to 2. Now, to write it as a exponential form, what we can do is we can first divide by 3. So we get 2 over 3 and then 10 to the power of 2 over 3. We could do that. We could also take it inside and make it a cube, right? So then in that case, it will be x squared plus 48x whole cube. And so cube root and cube will kind of cancel away, right? So let's do that part. So we'll rewrite this as log of is base 10 cube root of x squared plus 48x cube equals to 2. Now we can write this as an exponential form, and cube root will give you just x squared plus 48x, right? So we get x squared plus 48x equals to 10 to the power of 2, which is 100. So that gives you x squared plus 48x minus 100 equals to 0. Now, to factor, we can have 50 times 2 as 100. So we could write this as 50 should be positive and 2 negative. Correct. So that gives us two different solutions. So for x plus 50 equals to 0, we get x equals to minus 50. And for x minus 2 equals to 0, we get x equals to 2. Now, let us substitute in this particular equation and find, right? So what we'll do is we'll do cube root of cube root of x squared plus 48x. If I put minus 50 square, so let's write minus 50 square plus 48 times minus 50. What do I get? So let's use calculator. Minus 50 square will be 2500, and we have to take away 48 times 50, and that gives you 100. So it gives me cube root of 100. So we see it works because if I cube this, it'll be 100, and log 10 of 2 will be perfectly fine. So that works, right? Now let's also check the value 2. So if I substitute 2 here, right, so what do I get? Cube root of 2 square plus 48 times 2, which is cube root of 4 plus 96, which is also 100, right? So cube root of 100 really works, right? Since you know that 3 times log of cube root of 100 is indeed equal to 2. Perfect. And therefore, the solution is x equals to minus 50 and 2. Absolutely clear, right? So, in the first three questions, we really did not find any extraneous root. Let's go ahead and do question number 4. Question number 4 is 1 minus 2 log of x squared minus 3x within square root equals to 0. So let's bring it to the other side. So we have 1 equals to 2 log of square root of x squared minus 3x. Now, taking it inside, we get 1 equals to log of square of this will be x squared minus 3x. Writing it as an exponential equation, 10 to the power of 1 is 10 equals to x squared minus 3x. And that really gives us the quadratic equation, which is x squared minus 3x minus 10 equals to 0. 5 times 2 is 10, and therefore we could factor this as x minus 5 times x plus 2 equals to 0. X equals to 5 and x equals to minus 2 are the two solutions for this equation. Let us substitute this value within x squared minus 3x. So, if I put square root of x squared, let's say 5. So 5 squared minus 3 times 5, we get 25 minus 15, which is square root of 10. So that works. And if I do minus 2, then I get what? Let me change the ink. Minus 2 squared minus 3 times minus 2, which is 4 plus 6, which is also 10 square root, and that also works. So in this case, both are correct solutions. So we have our solution here, which is x equals to 5 and x equals to minus 2. Makes sense. So with that, we have done all the four questions. Each solution which we found was absolutely okay. None extraneous root in this set of four questions, right? So we'll move forward and see the next set where you might find extraneous roots. However, the concept is that whenever you solve logarithmic equation, it is a good idea to check. I hope that helps. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to best universities with even with scholarships. Well, we have come to the end of this video. Feel free to write your comments, share your views if you like, and subscribe to my videos. That'd be great. Thanks for your valuable time and all the best.